Hello guys, what's up? This is Sir EJ and welcome again for another math tutorial. In today's topic, we will be discussing all about the measures of variability. When we say measures of variability, it is a summary statistic that represents the amount of dispersion in a dataset. It simply tells us how spread out the values are. Unlike the measures of central tendency that describes the typical value, the measures of variability define how far away the data points tend to fall from the center. We will talk about the variability in the context of a distribution of values. If the measures of variability has a low dispersion or low variability, it indicates that the data points tend to be clustered tightly around the center. Low variability or low dispersion is ideal because it means that you can predict better information about the population based on the given sample data. While in high dispersion or high variability, it signifies that they tend to fall farther away. High variability means that the values are less consistent, so it is harder for you to make predictions. So why is measures of variability important? Variability is everywhere. Your commute time to work varies a bit every day. When you order a favorite dish at a restaurant repeatedly, it is not exactly the same each time. These are all examples of real-life variability. Some degree of variation is unavoidable. However, too much inconsistency can cause problems. If your morning commute takes much longer than the mean travel time, you will be late for work. And if the restaurant dish is much different than how it is usually, you might not like it at all. Some variation is inevitable, but problems occur at the extremes. Therefore, measures of variability helps us grasp the likelihood of unusual events. So let's have this example. You are investigating the amount of time spent on phones daily by different groups of people. So sample A, we have high school students. For sample B, we have college students. And for sample C, we have adult full-time employees. Using simple random samples, we will collect the data from three groups. All three of our samples have the same average phone use at 195 minutes or 3 hours and 15 minutes. So as you can see on the given figure, they all average 3 hours and 15 minutes or 195 minutes. So these are the x value where the peak of the curves are. Although the data follows a normal distribution, each sample has different spreads. Sample A has the largest variability, so this is sample A, the color blue, while sample C has the smallest variability. Let's have the first measures of variability, which is the range. So range tells us the spread of our data from the lowest to the highest value in the distribution. Also, it's the easiest measures of variability to calculate. So to find the value of range, we will simply subtract the lowest value from the highest value in the dataset. So our formula will be simply R is equal to H minus L, wherein R is equal to the value of the range, H is equal to the highest value, and L is equal to the lowest value. So let's have an example. Using the problem earlier, so these are the amounts of time spent on phones daily by high school students. So for the first high school student, he spent 200 minutes. For the second student, 320 minutes. For the third student, 218 minutes, followed by 405 minutes, 64 minutes, 98 minutes, 89 minutes, and 140 minutes. So the first thing we need to do is to identify the given. So which one is the highest value and which one is the lowest value. So obviously the highest value is equal to 405 and the lowest value is equal to 64. After that, we will be using the formula in computing the value of the range. R is equal to H minus L. We will just subtract the highest value minus the lowest value. So we have 405 minus 64 will be equal to 341. The range of your data is 341 minutes. Because only two numbers are used, the range is influenced by outliers and doesn't give us any information about the distribution of values. It's best used in combinations with other measures. So let's have the second measures of variability, which is the interquartile range. When we say interquartile range, it gives us the spread of the middle of your distribution. For any distribution that's ordered from low to high or ascending order, the interquartile range contains half of the values. While we all know that the first quartile contains the first 25% of the values, the fourth quartile contains the last 25% of the values. To get the value of the interquartile range, we will use the formula IR is equal to Q3 minus Q1, wherein IR is the interquartile range, Q1 is equal to quartile 1 or the lower quartile, Q3 is equal to quartile 3 or the upper quartile. So we will just simply subtract the value of quartile 3 minus quartile 1. So we have already discussed this on our previous video, how to solve for the quartiles of the group and ungroup data. So it is easy for us to get the interquartile range because we already know how to compute for the quartiles of the group and ungroup data. Let's have an example. So these are the amount of time spent on phones daily by the high school students using the same example. So these are the same given as earlier. So let's have the interquartile range. So to get the interquartile range, we need to compute first the value of quartile 1 and the value of quartile 3. So the first step we need to do, since this is an example of ungrouped data, we will be arranging this from the lowest score up to the highest score. So once you have arranged the number, we will locate the position of the score in the distribution by using the formula Qk is equal to k over 4 times the quantity n plus 1. Then, we will be substituting the corresponding value. Since we are looking for quartile 1, k will be equal to 1, and n will be equal to the number of students. So we have 2, 4, 6, 8. There are 8 students. So the value or the total frequency is equal to 8. So substituting the corresponding value, we have quartile 1 is equal to 1/4 times the quantity 8 plus 1. So 8 plus 1 will be equal to 9. And then 9 times 1 will be equal to 9 divided by 4 is equal to 2.25. So the position of quartile 1 is at 2.20th position. After that, we will be using the linear interpolation method. So quartile 1 is somewhere in between the second and the third number. So 2.25 is somewhere in between the second and the third number. So we will be identifying the second and third number. So this one will be the first number, second number, third number. So the second number is 89 and the third number is 98. And we will get the difference of these two. So 98 minus 89 will be equal to 9. After that, we will multiply 9 by 0.25. So 9 times 0.25 is equal to 2.25. And then 2.25, we will add this with our second number. So 1, 2, our second number is 89. So 2.25 plus 89 will be equal to 91.25. Next, let's compute for the value of quartile 3. So using the same formula, this time k will be equal to 3. So Q3 is equal to 3/4 times the quantity 8 plus 1 is equal to 9. Then 9 times 3, 27. 27 divided by 4 is equal to 6.75. So quartile 3 is somewhere in between the 6th and the 7th number. So 6.75 is in between the 6th and the 7th number. So we will count the 6th and the 7th number. 1, 2, 3, 4, 5, 6, 7. So this is the 6th number. This one will be the 7th number. And we will subtract these two numbers. So we have 320 minus 218 is equal to 102. And then after that, we will multiply 102 by 0.75. So 102 times 0.75 will be equal to 76.5. And then for the last step, we will add 76.5 by our sixth number. So our sixth number is 218. So 218 plus 76.5 will be equal to 294.5. So this will be the value of quartile 3. And then after we have get the upper quartile and the lower quartile, we will now get the interquartile range by using the formula IR is equal to Q3 minus Q1. Substituting the corresponding value, we have 294.5 minus 91.25 is equal to 203.25. So the interquartile range is equal to 203.25. Let's have the third measures of variability, which is the standard deviation. When we say standard deviation, it is the average amount of variability in your dataset. It tells you, on average, how far each score lies from the mean. The larger the standard deviation, the more variable the dataset is. So to compute for the standard deviation, we have the following steps to follow. First one is to list each score and find their mean. The second one is subtract the mean from each score to get the deviation from the mean. The third step is to square each of this deviation. Next step is to add up all the square deviation. Then divide the sum of the square deviation by n minus 1 for a sample or n for a population. And then for the last step, find the square root of the number you have found. So this will be the formula for the standard deviation. So if it is for population, we will be using this one. Population of the standard deviation equals square root of the summation of quantity of each value minus the mean raised to the second power all over the number of values in the population. In solving the standard deviation for samples, we will be using sample of the standard deviation equals square root of summation of the quantity of each value minus the mean raised to the second power all over n minus 1. So let's have our example. So using the same example earlier, these are the amount of time spent on phones daily by high school students using the same given, using the same data set. Let's now compute for the standard deviation. So the first step we need to do is to construct a table. So for the first column, this one is for the each value. So the value will be arranged in ascending or descending order. So we have 64, 89, 98, 140, 200, 218, 320, 405. And then this table contains a quantity x minus x bar, or each value minus the mean. And this column contains the quantity each value minus the mean raised to the second power. So after you have construct the table, you will get the mean by adding all these numbers divided by the total number of frequency. So 64 plus 89 plus 98 plus 140 plus 200 plus 218 plus 320 plus 405 is equal to 1,534, then we will divide it by the total number of data. So we will count the total number of data: 1, 2, 3, 4, 5, 6, 7, 8. So n will be equal to 8. So 1,534 divided by 8 will be equal to 191.75. So this will be the value of the mean or the average score. Next one, let's fill up this column. So we have each value minus mean. So we will just subtract these two numbers. So 64 minus the value of the mean. So 64 minus 191.75 is equal to negative 127.75. Next one, 89 minus 191.75 is equal to negative 102.75. Next one, 98 minus 191.75 is equal to negative 93.75. 140 minus 191.75 is equal to negative 51.75. 200 minus 191.75 is equal to 8.25. 218 minus 191.75 will be equal to positive 26.25. 320 minus 191.75 is equal to 128.25. 405 minus 191.75 is equal to 213.25. Adding this, we will get the summation of each value minus the mean. So getting the summation by adding these numbers, so we will get 0. So the summation of the quantity of each value minus the mean will be equal to 0. After that, let's get the summation of each value minus the mean raised to the second power. So we will just square this number. Negative 127.75 raised to the second power, or multiply it by itself, the answer will be equal to 16,320.06. Negative 102.75 squared is equal to 10,557.56. Negative 93.75 squared is equal to 8,789.06. Negative 51.75 squared is equal to 2,678.06. 8.25 squared is equal to 68.06. 26.25 raised to the second power is equal to 689.06. 128.25 raised to the second power is equal to 16,448.06. And 213.25 raised to the second power is 45,475.56. And then the next step is to get the summation of this number, the summation of the quantity each value minus the mean raised to the second power. So adding all these numbers or getting the summation of these numbers, we will have 101,025.48. After we have filled out all the values on the table, we will now identify if we are dealing with a sample or population. So in this problem, we are only dealing with sample because our problem is all about the amount of time spent on phone daily by high school students. So we have only 8 data samples. So 8 students participate the survey. So because we are dealing with a sample, we will use the formula S is equal to square root of the summation of the quantity of each value minus mean raised to the second power all over n minus 1. We will substitute the corresponding value. So bring down S equals square root of the summation of each value minus the mean raised to the second power is 101,025.48. The value of n is equal to 8 because there are 8 students who participated on the survey. So we have 8 for this, and then 8 minus 1 will be equal to 7. And then dividing these two numbers, 101,025.48 divided by 7 is equal to 14,432.21. And then let's get the square root of this number. So the square root of 14,432.21 is 120.13. Therefore, the standard deviation of our data is 120.13. This means that on average, each score deviates from the mean by 120.13 points. The last type of measures of variability is called variance. When we say variance, it is the average of square deviations from the mean. A deviation from the mean is how far a score lies from the mean. Variance is the square of the standard deviation. This means that the units of variance are much larger than those of a typical value of a dataset. While it's harder to interpret variance number intuitively, it's important to calculate variance for comparing different datasets in statistical tests like ANOVAs. Variance reflects the degree of spread in the dataset. The more spread the data, the larger the variance is in relation to the mean. So to compute for the variance, we will just square the standard deviation. We will just get the square of the standard deviation. B is equal to S squared for the formula of the variance, wherein B is equal to the variance and S is equal to the standard deviation. So using the problem about standard deviation, we have computed earlier that the standard deviation is equal to 120.13. So to compute for the variance, we will be using the formula B is equal to S squared, and we just need to square this number. 120.13 raised to the second power, multiply it by self, will be 14,431.22. Therefore, the variance is equal to 14,431.22.